Hello, everyone. Thank you for joining. We'll just wait 2 minutes more and allow a few more participants to join, and then we'll start shortly. Thank you. Good afternoon, everyone, and thank you for joining us. Good to see so many people logged in this early. It's always a good sign. So I think, Mr. Prosper, we can begin today's session. It's already 3:30. So for the benefit of the people who've already joined, let's begin. Can't hear you, Mr. Prosper.
Yes, we can.
All right, perfect. So let's begin. Okay, so good afternoon, everyone. Thank you for joining us once again. Um, Today, this session is about something very fundamental in water treatment: filtration. Is filtration media and why it deserves a fresher look? This webinar is brought to you by NatureWorks in association with Pure Water Enterprises. I am Rahul Mehta and I work as the Business Development Manager at Pure Water Enterprises, and I will be moderating this session for you today. We have with us Mr. Prosper Linus and Mr. Viplav Srivastava from the NatureWorks India team, along with Mr. Guillermo, Mr. Alberto, and Mr. Javier from the NatureWorks Spain team. We also have with us the founder of Pure Water Enterprises, Mr. Sanjay Mehta, present today. So we will briefly introduce Pure Water Enterprises and NatureWorks, then move into glass filter media, how it differs from sand, where it delivers value, and finally, real case studies followed by a question and answer session. We promise to keep the slides light and the discussion very, very useful. We are looking forward to a very interactive session with active participation from the audience. There will be a Q&A segment wherein attendees can type in their questions as the webinar progresses, and we will take them for answering at the end of the session. Perfect. So Pure Enterprises has been working in the water and the wastewater treatment industry for the past 28 years. We work very, very closely with OEMs, consultants, and end users all across India, mainly in the reuse, recycle, and advanced treatment applications. As a company, it has always been an endeavor to bring proven world-class global technologies to the Indian market and conditions. Whether it is Veolia's UF, RO, NF, and MBR membranes, Purolite's specialty ion exchange resins, Energy Recovery's pressure exchangers and booster pumps, and Xylem's submersible mixers and UV, and even NatureWorks' glass filtration media. We always strive to get the best technologies in India. On the other hand, NatureWorks is based in Alicante in Spain and specializes only in glass filtration media. This focus is extremely important as this is not a side product for them. It is their core expertise. NatureWorks operates in over 45 countries with more than 200,000 installations. That's 2 lakh installations all across the world. We also have approximately 200 plus installations in India, and this number is growing very quickly across various industries and applications. The manufacturing process followed at the NatureWorks facility in Spain is 100% renewable powered, which speaks even more to their unwavering commitment towards sustainable practices. 30% of the total energy is self-generated photovoltaic panels installed in their facility, whereas the other 70% power comes from a regenerable power grid running on a combination of wind, solar, and hydraulic energy. Speaking more towards a logistical point of view, NatureWorks is based in Alicante in Spain, and it has direct access to the world's major ports through the Valencia port. In the next few slides, we will walk you through the various state-of-the-art facilities at NatureWorks Spain factory. What really matters here is consistency and control over even the smallest steps in the entire manufacturing process. Through continuous investment in R&D and product development, NatureWorks makes sure that their glass media is constantly evolving and keeping up with the advancements in market and the market needs. Every step of the manufacturing process is entirely controlled. The facility adheres to the highest standards of sanitation and cleanliness, reflected by numerous certifications, such as the NSF 50 and NSF 61 certification. And the automated packaging ensures that every batch performs the same. Consistency and predictability is key in filtration applications, and our glass media helps achieve just that. So let's take a step back now. Sand has been used for water filtration applications for the past 200 years. It is reliable and gives acceptable results, but it hasn't evolved since. Meanwhile, everything else around it, including the vessel, the internals, automation, everything else has advanced. This results in a huge gap, limited efficiency, higher water use, higher energy consumption, water channeling, and biofouling, all of which can seriously hamper the efficiency of a filtration system. That's the issue that we are going to address today. So what I'll do now is quickly put up a poll for all of you to answer. I hope it is visible on the screen now. It's a pretty simple question, and it will help us understand how the attendees are placed today in terms of their prior exposure to glass filtration media. I'll just give a minute for everyone to log in their responses before I share the results. Okay, so I will publish the results now. Here are the results. As you can see, a huge chunk of the attendees have not used or even heard of glass filtration media before. We will work on remedying that today by deep diving into our glass media offerings and how we can add real value to your processes. So NatureWorks glass media is specifically engineered for a very accurate particle shape, size, curvature, and surface. Hence, it is controlled in nature and very uniform. It is not just crushed glass, it is engineered glass. This allows uniform flow paths, higher effective surface area, long life, leading to outstanding filtration, and eventually significant water and energy savings. On the long life subject, they actually have case studies where the life of the glass media has even surpassed the life of the vessel itself. So now I would love to bring on Mr. Prosper Linus, the country head of NatureWorks India, to take over from here to introduce our glass media offerings and subsequently talk about its comparison with silica sand in every aspect, specific applications such as UF and RO membrane protection and side stream filtration in cooling towers, and finally end with 3 real-world case studies from varying applications and industries. So over to you, Mr. Prosper.
Thank you, Rahul. And thank you all those who are attending this. As I was introduced, I'm Prosper Linus. I'm heading the operations in India, along with my colleague, Mr. Viplo Srivastava. So I'm excited to take you through the rest of the presentation, and I hope this will be useful to you. Let's start. This is NW40, by far our most widely used glass filter media for industrial and wastewater applications. Besides some very fine filtration, the most important point is compatibility. The NW40 can be used in existing sand filters, so customers don't need to change vessels or internals. It is NSF 50 certified for industrial use and manufactured from recycled, cleaned, multicolor glass, primary green in color. What really differentiates it is the anti-compaction technology, which keeps microchannels uniformly open, preventing caking, channeling, and pressure drop buildup over time. This is our premium high-tech glass filter media, the flagship product of our company. It is the only glass filter media in the world certified to NSF 61, which makes it suitable for drinking, for pharmaceutical applications, and other sensitive ones. It is manufactured from virgin white flat glass, ensuring very high purity and consistency. Like NW40, it uses anti-compaction technology, but this product is typically selected where regulatory compliance and water quality standards are extremely stringent. Unlike sand, NatureWorks glass media offers very precise and consistent grain curves. On our NW40 media, it's available from coarse support layers all the way down to stage 2 fine filtration. This allows us to design multi-layer filters with predictable head loss, filtration efficiency, and backwash patterns. From the supply and logistics standpoint, the NatureWorks glass media is supplied in both 20 kg bags for smaller installations and 1000 kg big bags for larger municipal projects. This makes handling, loading, and logistics simple, whether it is a retrofit or a greenfield installation. Now that we have understood what the media is and how it is configured, let us deep dive into how it actually performs compared to silica sand. Before we go into the details, let us step back and summarize where glass media clearly outperforms silica sand. There are four clear advantages. Firstly, filtration performance, especially for fine turbidity and total suspended solids. Secondly, water and energy efficiency, driven by lower pressure drop and fewer backwashes. Thirdly, durability, meaning stable performance over many years. And finally, overall cost savings, which come from all of the above. I will now take you through each one of these in more detail. Let us first look at filtration performance, as this is the most important role. Glass media excels at removing fine turbidity and colloidal particles. This is where sand struggles. The most important point here is biofilm. Sand has pores where bacteria settle and grow, leading to clogging and channeling. Glass media has a flat surface where bacteria simply cannot anchor themselves. As flow distribution is uniform, the risk of channeling is drastically reduced and filtration performance remains consistent over time. Let's try and put some numbers to quantify the difference. NatureWorks glass media can typically retain particles down to 1 micron, whereas silica sand generally retains particles in the 20 to 40 micron range. These results are based on tests conducted by IFTS in the presence of a notary. At a filtration velocity of 20 cubic meters per square meter per hour, over 60% of particles below 1 micron were retained. This is why you see visibly clearer water and better downstream protection. The full IFTS report can be scanned from QR in your right bottom. Alternatively, we can share the same with you if required. Now let us move into the energy and water efficiency. The biggest contributor here is the lower head loss over time. Glass media has a very smooth, non-porous surface and uniform particle size. Dirt stays on the surface instead of penetrating pores. As a result, fouling is slower, mud ball formation is eliminated, and pressure drop remains low for much longer. This translates into continuous energy savings and not just during backwash alone. Then we come to the frequency with which glass media needs to be backwashed. Due to the fact that the entire surface area of the media bed is available to capture the total suspended solids, unlike sand, which compacts and forms channels frequently, glass media's backwash requirement is delayed significantly. Backwash frequency reduces typically by 50 to 80%, in most cases more than 80%. This is intermittent saving. The NatureWorks glass media cleans far more easily because dirt is held on the surface, backwash requires lower velocity and shorter duration. In most installations, backwash time reduces by about 30 to 40%, and the pumping head required is significantly lower. This directly reduces power consumption and treated water losses. So basically, you save water by lesser number of backwashes, lower duration of each backwash, and each backwash is at a lower velocity. Power savings are not one-time or occasional. Every pump in a filtration system is designed for a particular head. When delta P stays low, the pump works closer to its best efficiency point. With glass media, this condition is maintained for a much longer period. Let us put realistic numbers to power savings and using conservative assumptions. Consider a filter operating at 100 metric cube per hour. If glass media reduces the average operating pressure drop by just 0.3 bar, that is roughly 3 meters of head, in a typical pump efficiency, this translates to about 0.8 to 1 kilowatt lower power drop per filter continuously during operation. If the filter runs for about 20 hours a day, that is roughly 16 to 20 units of electricity saved per day. Over the year, this adds up to 5,000 to 6,500 kilowatt hours per filter without changing pumps, motors, or operating philosophy. Now I'll just hand it over to Rahul for the second poll, and then I will come back.
Thank you, Mr. Prosper. So I will be putting up another poll, and I request everyone in the audience to just put up the answer. Thank you so much. I hope the poll is visible on the screen right now. Again, I'll give a minute for everyone to log in their responses before I share the results. Okay, perfect. So here are the results. As you can see, water savings, energy savings, reliability, and lower chemical consumption, all parameters are extremely important when considering filtration upgradation. Glass media helps with all these parameters in its very own way. I'll hand it back to Mr. Prosper to take it ahead. Thank you, Mr. Prosper.
Thank you, Rahul. Another major advantage is durability. Unlike sand, glass media does not cake, compact, or break down over time. This is virtually no attrition loss. This means filtration performance remains consistent year after year. A well-operated NatureWorks glass media has life of 15 years, can exceed 20 years too. Capital costs. NatureWorks glass media as compared to sand is definitely high. But you combine all the above factors, lower backwash water, lower pumping energy, reduced chemical usage, and longer media life, the overall operating cost reduces significantly. Even though glass media costs more initially, the life cycle cost is substantially lower compared to silica sand. And again, I stress the much better filtration quality is the real game changer. There are so many plants operational in India today with just sand filters as pre-treatment to RO plants. The NatureWorks glass media can really upgrade the performance of the RO systems. Similarly, there are many UF plants facing suspended solid loads higher than design, especially in wastewater treatment, where inlet parameters keep on changing. A NatureWorks glass media upgrade can surely make the UF or RO systems work exceedingly better. We have many such instances wherein the small cost of shifting from sand to NatureWorks glass media has made the operations very smooth and consistent. Sand filters are typically backwashed at a pressure drop of about 0.8 to 1 bar because beyond this, pore plugging and mud ball formation accelerate. Glass media, on the other hand, should be backwashed earlier at around 0.45 to 0.6 bar. Beyond that, there is no benefit because dirt is already surface held. But although the trigger delta P is lower, the rate of pressure drop buildup is much slower, which is why overall backwash frequency reduces by 50 to 80%. The NatureWorks glass media is not just a drop-in replacement for sand, it is a genuine upgrade at possibly the lowest capital cost. We strongly believe that this is one product which punches much above its weight in terms of efficiency, consistency, durability, and affordability. This slide explains why backwash frequency reduces. In sand filters, solids migrate into the pores of the media. As these pores clog, the effective filtration area keeps reducing. The filter starts working harder by the hour. Glass media behaves very differently. Solids are retained on the top layers while the rest of the bed remains hydraulically open. This means that the entire cross-section of the filter continues to work, which is why pressure drop rises slowly and predictably. A good product becomes a great solution when it is backed by strong technical support and service. Very often, the first question we get is, how do we design this correctly? For existing vessels, we work with the plant flow rate, inlet TSS and turbidity, vessel diameter, height of shell, and existing bed depth. For new projects, we start with the flow rate, inlet water quality, and outlet requirements to design the vessel and media accordingly. We prove design support from selecting the right glass media grades to calculating exact quantities and layer-wise distribution. For standard FRP vessels, we already have design calculations, which means that we can support projects immediately. For customers who want to validate performance before full-scale implementation, we encourage joint pilot trials. In such instances, we support on-site trials by supplying glass media for small vessel quantities at supportive prices. Trial data is shared and reviewed jointly, which allows us to optimize the final full-scale design. This approach ensures that when the system is commissioned, filtration performance is predictable and reliable. The attached photo of the pilot was done by an OEM customer who later converted this into a 14 metric ton glass media order for a replacement to sand in a UF RO system. Now let us talk about something which I'm sure is on everyone's mind. Where does the ROI of glass filter media come from? Rather than using generic assumptions, we offer project-specific ROI evaluations based on actual plant operating data, existing filtration performance and backwash practices, local water, power, and chemical costs, proposed glass media configuration, and operating philosophy. This ensures informed decision-making before implementation. ROI calculations are available on request. This is what our ROI sheets typically look like. We take into consideration a lot of various site-level parameters and come up with calculation which can come closest to real-world results. The ROI or financial return from glass media is not driven by one single factor, but by many continuous and operating savings such as reduced backwash frequency and backwash water column, lower and more stable pressure drop across the filter, reduced pumping energy for filtration and backwashing, lower chemical consumption due to improved filtration quality, elimination of frequent filter media replacement, better membrane performance of UF and RO. These savings operate continuously 24/7 over the entire life of the filter. ROI is different for every installation and varies from site to site. The payback period for glass filter media depends strongly on site-specific operating conditions, such as inlet water quality, which means suspended solids, turbidity, seasonal variations taken into account, existing backwash frequency and duration, cost of power, water and treatment chemicals, daily operating hours of the filtration system, condition and age of existing filter vessels and internals. To give you a simple example, a lot of our OEM friends blindly use glass media for their export orders. The issue is sand export, dependable performance and sand cost abroad is very high, and the ROI is virtually immediate. This is why generic ROI numbers can be misleading. A typical payback experience based on field installations across industrial, utility, and infrastructural applications, the following trends are commonly observed. Installations with high backwash frequency or high suspended loads recover investment faster. RO pretreatment and cooling water side stream filtration show strong and consistent payback. Most industrial installations achieve payback within 12 to 24 months. In severe operating conditions, payback can be even shorter. In critical applications where outlet quality is stringent, the glass media ROI is shortest. Longer media life, above 15 years, ensures savings well beyond payback. This is a graph depicting the exponential cost it takes to run a filtration system with silica sand as compared to glass filter media. So far, we have spoken about how glass media works and why it performs better than sand. Now let us shift gears and look at where this actually delivers value for customers. You will notice that these applications are very different from each other, but the common connect is the need for extremely consistent filtration, lower fouling, and operational stability. Let us start with RO pretreatment, probably the most common and most sensitive application. In RO systems, the end goal of filtration is very simple: protect the membranes. Glass media helps achieve lower and more stable SDI and turbidity, even when inlet conditions fluctuate. The result is reduced RO fouling, longer CIP intervals, lower chemical consumption, and ultimately longer membrane life, whether the RO is preceded by UF or not. If there is a UF, the glass media shield helps it to work at its highest efficiency. No unplanned backwashes, no chemically enhanced backwash cleanings, allowing the UF membranes to work at a designed flux. If the UF is not there, then the glass media's responsibility increases as it directly takes on the complete load of fine filtration. So if you have a particular challenge of no UF system with higher suspended solid load, the simplest solutions remains changing sand to glass media. Virtually no retrofit challenge, and the plant is up and going in a couple of days' time. I want to pause here and talk about SDI because SDI is often misunderstood. SDI is not just a compliance number, it is an indirect indicator of how much fine particulate matter is entering your RO membranes every day. What is important to understand is that SDI does not behave linearly. A small change in SDI represents a very large change in the particulate load. An RO system operating at SDI 4 behaves very different from the one operating at SDI 2, even though the numbers appear close. Now let us look at what this means in real operation. Higher SDI accelerates fouling, increases pressure drop much faster, and forces more frequent CIP. Every CIP means chemicals, downtime, membrane stress, and cost. RO membranes fail not only because of one bad day, they mainly fail because of weeks and months of unstable feed water quality. This is where glass media adds real value. Glass media does not just reduce SDI, it stabilizes SDI even when inlet conditions fluctuate. That stability directly translates into longer CIP intervals, lower chemical consumption, and longer membrane life. Now we'll take you through various applications. Raw water filtration is where sand filters are most challenged, especially during monsoon conditions. River water brings in fine silt, colloidal particles that are difficult to remove consistently with sand. River water brings in fine silt and colloids also. Glass media handles this much better even under high silt loading. Backwash frequency remains lower and filtration quality stays stable. This protects downstream systems and avoids operational surprises during seasonal changes. Side stream filtration, where glass media delivers some of the strongest performance and economic returns. In cooling systems, fine suspended solids keep circulating and contributes to biofilm formation, fouling, and higher blowdown. Glass media removes these fine circulating solids far more effectively, which significantly reduces biofilm formation in the cooling circuit. This allows higher cycles of concentration, lower blowdown, and substantial savings in water, energy, and chemicals. We are soon releasing a white paper on glass media for side stream filtration with a special focus on power plants. We will be sending this document to all of you as part of our post-webinar offering. I now want to step slightly away from filtration and talk about cooling system behavior. Most of us are familiar with the classic cooling water triangle, which is fouling, microbial growth, and corrosion. What is important to understand is that these three problems do not occur independently. They feed each other. Fouling provides a physical surface where microorganisms can attach and grow. Once biofilm develops, it creates differential oxygen conditions and accelerates corrosion. Corrosion products then break loose and re-enter the system as suspended solids, increasing fouling further. At the center of this triangle is something we often underestimate: fine suspended solids. These fine particles are small enough to remain in circulation, large enough to deposit on heat transfer surfaces, and sticky enough to support biofilm formation. Chemical treatment can control parts of this triangle, but it cannot remove suspended solids. That is where side stream filtration becomes critical. By continuously removing fine circulating solids, effective side stream filtration weakens all the three sides of the triangle at the same time. This is why fine filtration in side stream filter is not about clarity. It directly reduces fouling, limits biofilm development, and lowers corrosion risk simultaneously. Glass media performs particularly well in side stream filtration because it consistently removes fine suspended solids without rapid fouling or frequent backwashes. The next application is swimming pools, which is a very different application, and expectations are actually very high. The water must look crystal clear, remain hygienic, and perform consistently even during peak usage. Glass media delivers visibly clear water, minimizes biofilm formation inside the filter bed, and maintains stable performance during higher loads. This improves hygiene while reducing operational intervention. In fact, the swimming pool application is where the glass media journey actually began in Europe. Some industries just require an elevated level of filtration protection. Initially, it was pharma and bottled water industry, and now the solar and semicon industry are added to this list. Here, consistency and compliance matter more than anything else. Glass media provides stable filtration quality, prevents bacterial growth inside the filter bed, helps better stringent outlet norms. The availability of 2 grades of NSF certified glass media makes it suitable for these sensitive applications where reliability cannot be compromised. Now over to Rahul again for poll 3. Yeah, Rahul, take.
Thank you, Mr. Prosper. And thank you everyone for staying on for so long. I'm just going to put up our third and the final poll for the day. And yes, I request everyone to just put in the answers. Thank you so much. I hope it is visible on the screen right now. And also thank you very much. We have more than 150 people attending today's session. So thank you so much to everyone for attending and staying on for so long. It matters a lot. I'll just give a minute for everyone to log in their answers before I publish the results. Perfect. So I hope the results are visible. So as you can see, reduced backwash and pumping power are really important factors to make calculated decisions when choosing the right filtration media. And I'm happy to say that a lot of people have said yes and also agreed to trials with our OEMs and customers. You can get in touch with us to know more about our collaborative pilot trial program after the webinar. Over to you, Mr. Prosper.
Thank you, Rahul. Now I want to take a step back from technology for a moment and talk about decision making. Today, there are several technologies available that can deliver fine filtration, ultrafiltration, automatic self-cleaning filters, cartridge-based systems, and others. All of these technologies work, but they are essentially new projects. They require new equipment, additional space, civil work, integration with existing hydraulics and automation, and most importantly, time to stabilize. Now let's look at the reality on the ground. There are tens of thousands of sand filters already installed in cooling towers, RO pre-treatment systems, and industrial water plants. When these systems face suspended solids or fouling issues, customers have two choices. One first option is to introduce a completely new filtration technology. Second option is to upgrade what is already working. Replacing sand with glass media is not a new project. It is a retrofit, quick to implement, easy to stabilize, and highly cost-effective. Glass media does not try to replace advanced filtration technologies. It offers the simplest, fastest, and most practical upgrade path for existing systems. Sometimes the smartest upgrade is not a new technology. It can just be about making existing infrastructure work better. You have now seen where glass media is applied. Let us now walk through a few installations, real time, that show how this performs under actual operating conditions. These are not pilot setups, but working plants. First case study is from a chemical industry effluent treatment plant in Gujarat. The plant treats effluent from a pigment manufacturing industry with an inlet suspended solids of over 100 ppm, and turbidity close to 40 NTU. Because this was a new project with UF and RO downstream, the concern was clear. The sand media filter would choke frequently under such high inlet loads. The decision was taken to use glass media right from the beginning with a dual layer configuration. We owe it to the passionate OEM and the receptive end customer. They were very helpful. From our side, we were involved in the installation and commissioning process. So in the end, it was a joint win. Once commissioned, the outlet suspended solids was below 10 ppm continuously, and turbidity reduced to below 5 NTU. Most importantly, filtration performance remained stable, protecting the UF and RO systems without frequent intervention. It is now more than 18 months since the installation is in place, and the results are the same every day. This is not about improvement on sand performance. It is about avoiding its limitations. The second case study is from a textile industry effluent treatment plant in Maharashtra, handling about 125 to 135 metric cube per hour, and its replacement case study. The plant already had filtration in place, but the outlet suspended solid was high, leading to frequently choked cartridge filters, reduced UF membrane life. The backwashing was required every 8 hours, and the extended UF cleaning happened every day, which meant shortage of treated water for manufacturing, huge cost in buying additional water, increased chemical consumption, overall high water loss, and a constant management attention. Now, after replacing the existing media with the NW40 glass media, backwash frequently reduced once a day, outlet suspended solids dropped from 74 ppm to around 6 ppm. This immediately stabilized downstream operations and reduced operational stress. In this case, the biggest gain was not savings, it was stability. And the final case study is a municipal sewage reuse project in China. This installation uses 32 filtration units, treating recycled water at a total flow of 650 metric cube per hour, primarily for UF protection. The very large international filtration company used our glass media for this large installation. So as you can see from the results shown on the slide, the performance exceeded customers' requirements. Our glass media was selected for its consistent filtration behavior, predictable backwash characteristics, and long service life, ensuring stable operation across all units. At this scale, predictability matters more than optimization. Now, in conclusion, filtration media is no longer a small component in the treatment system. It directly influences performance, efficiency, and operating stability. Sand has served the industry well, but today the operating conditions demand more consistency and control. Processed water is just too costly and scarce to waste. NatureWorks Glass Media addresses these challenges by delivering stable filtration, lower fouling, and long-term efficiency. And finally, a good product becomes a reliable solution when it is supported by strong technical expertise and service. A big thank you from all of us here at Pure Water and NatureWorks for your time, attention, and interest. We sincerely appreciate it. We now are happy to take your questions. Thank you once again. Over to Rahul.
Thank you. Thank you so much, everyone, for attending our webinar. I hope it was enlightening, and I hope it gave you some real insights as to what our product actually is. where it might be applicable to you in your processes, how it compares to sand, the specific applications where you might find use for glass media, and finally, I hope the case studies really helped you understand how glass media works in real conditions under really tough to treat affluents. And yes, we are open to questions. I can see that a lot of participants have asked questions, and I think Mr. Prosper, we can start taking a few questions from the chat box itself and start answering them. Right?
Yeah, yeah. Can
Perfect.
someone read out
So,
the questions for me?
okay, perfect. I'll do that for you. So, one of the questions is glass media suitable for potable water purposes? If yes, then how glass breakages and its traces in the treated water are being ensured for zero presence?
Glass media is not subject to any breakages because we have done an MOHS strength testing for the grains, and MOHS, it stands at MOHS 7. Now, if you Google MOHS and check out, 7 is very close to 10, which is the highest, which is of course diamond. And so there are no breakages. And for the last 15 years, we have no attrition loss, no replacement, no what we call addition of media or any other complaints from drinking water segment with regard to glass being present in their drinking water. So you can be rest assured that our media is strong enough to not break, and there is no collision because the pressure within the shell is very less compared to what you have in other medias. So it doesn't break.
We hope that answers your question, sir. The next question is any size limitations? What is the maximum flow that it can be designed for?
Whatever maximum flow you design your sand, the silica media can be designed for glass media.
Exactly. Another question is what is the pressure requirement for operations?
Pressure requirement is 1/3 that of any sand media.
Perfect. A certain Mr. Yogesh asked us, how do you help in piloting? Mr. Yogesh, my contact details are right in front of you on the slide. You can get in touch with me. We encourage collaborative pilot trials with our customers, and we can definitely support you with this. We have pilot plans ready with us, and we can also work with you if you have any other thoughts in mind. Another question is, what would be the feed limiting parameters?
Practically, we have tested up to suspended solids of up to 200 and got 95% reduction in the suspended solids. There are case studies which have been done very early in our, NatureWorks, when it was introduced initially with in my local city itself. So we have done a lot of piloting, and we found one which was extremely high. So about 180 or 185 ppm of suspended solids, which we brought down to about 10, close to 10 to 12. So that's very commendable. I don't know whether, Rahul, you have any case studies which is higher than that.
We more than 180, I think we do. We can share all the case studies with all the attending participants right after the.
Fine.
Yes. One question is, how do we design glass media quantity? So you can get in touch with us regarding any inquiry that you might have. If it's a direct replacement of sand, all we need is the size of the vessel, that is the diameter and the HOS and the flow rate, and we can help you with the exact calculations. And if it is a new greenfield project, then all we need is the inlet parameters and the flow rate, and we can help you with the exact quantity required for your particular inquiry. Okay, this is a very important question. Are filtration and backwash velocities the same as sand filter or different?
No, it is different. It is different in the sense the velocity always depends on your filtration velocity. So the percentage of the velocity will depend on the filtration velocity. It all depends on how you set your filtration velocity. Now, if you match it with sand, then perhaps it will be the same. But the pressure required is much, much lesser. So the velocity may be the same.
Okay. We have observed that usually it requires a lower backwash flow rate, eventually um, leading to a lot of water savings, right, Mr. Prosper?
Yeah. That is because of the, the timing that it takes, the delayed backwash. You don't do it as
As
frequently that
often.
you do the sand. So, that all that saves you water, energy, and time. I will also include manpower, because every day or
Right.
3 times a day that when manpower has to be there to monitor the differential pressure and go in for a backwash. But here that is not required. You can by a trial and error, you will know more or less in how many days you have to do one backwash. So you don't have to have a dedicated person there. But these
That's
are all
right.
the savings that one can have.
Right. Very interesting question, actually. Can glass media completely eliminate UF? Less than one SDI required.
We won't commit all those things right now. It's all left up to the industry to check for themselves. To see,
Right.
UF is something to protect the RO, or sometimes UF is just a dedicated separate one for applications where RO is not required. So it all
Right.
depends on what is the application, what is the result you want. So it all depends on that. It is all application based. So you can get in touch with us so that we can design it accordingly, whether UF is required and whether this can directly be sent into an RO. Yes,
Right.
those piloting we can do, of course, and we can see how best this can work. But we will not write it down and give it to you that it can replace our UF at all.
Yes, I think we have a particular media, the high-tech stage 2 media, which the size of which is 0.4 to 0.7 mm. We can run trials with that. I think we get some very impressive fine filtration results
Absolutely, absolutely,
when you
yeah,
run that at a low velocity. So,
correct.
so you can definitely get in touch with us, and we can arrange some trials and
Yeah,
see how we can
like you said,
see
Rahul, the
matters a
velocity
lot.
matters a lot. So when the
Right.
velocity reduces, then of course you have a more surface area for the capturing of the
And
particulates.
and gets you that much closer to the quality of
Ab-
water required to put
Yeah,
into the RO.
exactly,
Right.
exactly.
Thank you for the question, sir. Another question is chemical treatment required with glass media in side stream filters?
See, normally in sand media, you use chemicals like, clogging, like, sort of alum or, poly and all that stuff you use to create a better, bigger lump to filter out the particulates. That is not required here. Maybe
Right.
it is not required to a great extent. I won't say completely not required, but not required to a great extent.
Perfect. Can we use glass media to recycle the swimming pool water?
Recycle what?
The swimming pool water.
NatureWorks is the master in swimming pools world
That's right.
over. They have done swimming
We
pools.
have a lot of case
Nobody
studies. We
can
can.
nobody can match them as far as swimming pool are concerned. They are masters. So swimming pool,
Right.
yes, it is a walkthrough for us.
Perfect. Um, Another question is glass media compatible with ClO2 dosing?
It is chlorine tolerant. It is chlorine tolerant.
Chlorine and chlorine dioxide tolerant, yes.
Chlorine tolerant. Yes, it is chlorine tolerant. See, glass is very inert. It is very,
Right.
temperature tolerant, chlorine tolerant. So all these things will not affect glass media at all.
Right. What SDI level can be achieved with glass filtration media?
Again, we have a case study long time back in my city here. We brought it down to less than 2 or 3, I think. I'm not mistaken. I'll have to check that. I'll share that with you, Rahul. You can share it to them.
I can share that with the yes concerned
Yeah,
individual. Yes, for sure.
Yeah.
The
I think it is
specific
in our website. Rahul, it's in our website.
sure. I'll share all the
Yeah, yeah.
information with
The
the
STI
concerned.
part is in our website. Yeah, I remember.
I'll do that. Thank you for that. Does this technology reduce algal blooms in aquarium or water tanks? That's an interesting question.
See, when you recirculate open water body or any um, where algae develops because of sunlight, and then that has to be it can be recirculated and removed. But of course,
Right.
it all depends on the sizes of the what micron it is, and how much load is there. Your backwash frequency will vary,
Right.
but it can be done.
We have case studies, right? I've seen Nature Works work with a lot of
Yes,
aquariums.
yes, yes.
Yes,
In
we
their
can
what
definitely share that.
correct.
The special. What will the absorption? What is the absorption rate? What is it compared? What is the comparison rate of the same compared to silica sand?
I'm
Absorption
asking
rate.
about
I
the
believe
rate
yes.
or what is it?
Absorption rate. I believe
No,
that.
this is a physical filtration media.
Right.
It does not absorb or adsorb. It just
Right. It filters.
contains particle matter on its surface, and you'll have to backwash it out of to the tree.
It does exactly what sand media does, but a lot better.
Exactly. It doesn't
Yeah.
absorb or adsorb. Yeah, no.
Right. What is the maximum TSS the media can handle? I think we mentioned, did we answer that
We
earlier?
just mentioned that earlier.
Yes. We have used it for TSS loads up to 200 ppm and it does a good job at filtering the. Yes. What is the specific gravity of the media and maximum temperature that glass media can withstand?
Specific gravity is there in our data sheet. It's 1.335.
1.335,
Stage
correct.
1. Stage 2, it will be slightly more. So it is 20% lesser than sand. Sand is 1.670.
6. Yes.
1.6, this is 1.3.
Right.
So lesser quantity, 20% lesser quantity for the same column, for the same capacity.
Right. Someone has a question, like actually more for concerned. Surface is smooth, so microbes would not stick, but then it will flow further.
Microbes in water, we are not filtering out microbes in the water. We are avoiding microbes to develop on the media. And
Right.
as a media, as a surface, it allows microbial growth. We avoid that. But otherwise, we don't filter out microbes. That you have to use a UF or RO membrane.
Right. Very different applications.
Yeah, of course.
Yes. What is the maximum pH that it can handle?
pH, I'm not very conversant with the pH, but I think it is pH tolerant.
It is pH tolerant.
So far,
yes.
So I have never given a thought to it, but I think it is pH tolerant.
Yes, it's very inert in nature, so I do not think pH would have a huge impact.
It is temperature tolerant. It can take up high temperature. Everything. It is inert.
Just all. Yes. What should the bed depth compared to the sand media be?
Same. We recommend 1 meter for better efficiency, but then it all depends on the size of your height on straight, and depending on that, we give 60 to 70% filling. That is, your bed depth, and remaining 30 to 40% as freeboard. So it again all depends on applications. 1 meter to 1.2 meter is ideal.
Right. Please share the actual cost of glass media versus sand media wherever you achieve results. Like for example, textile India at Maharashtra. For sure, so we can arrange that. You can get in touch with us. My contact details are right there, and we can share the specific numbers related to the case studies. Two-stage and series filtration can be adopted. Yes, sir, it can be adopted. Right? Two-stage series filtration can be adopted for glass media, right, Mr. Prosper? Double stage?
We we don't recommend. We always recommend single layer, but some of them are adopting multi-layer.
Yes.
The only thing is your bed depth, your filtration bed depth gets lesser because ours is an in-depth filtration. So we always recommend single layer. It's better to go for single layer. When tomorrow, practically, when you want to shift your media to a new vessel because the vessel has become old or broken or whatever, you won't be able to do that if you have more than one media in a vessel. It's very difficult.
Yeah.
So that way you may have to go in for a new media. But then single layer is always. I don't understand why you have to go for multi-layer, because given the application, we choose these layers for you. We choose the grade for you. We
I
have a
think another. I think there's some confusion. I think what I think is that the question was, can it be used as like in two columns basically, one after the other, double
absolutely,
pass?
absolutely. You can
It
use
can be.
stage 1, then you can go for stage 3. Stage 3 gives you a very fine, especially for pharma and all that. All
Right.
those
So basically, it can be used as a double pass. Basically,
yeah.
two
You
columns.
can
The
go
outlet
at
of one can be put in as
go at
in the
50
inlet of.
meters. Yeah.
Right. What is the criteria to be considered to replace media, the glass media? I don't think we have ever replaced glass media before, right? In any.
There's nothing to be considered
Yeah.
as long as it is operated well, and then the regular backwashes are happening, nothing will happen.
Right. Does glass media affect the vessel size? Should vessel size be increased or decreased, or should it remain the same as what is taken for sand media? I think that's a good question.
If you compare it with sand, you can go in for the same vessel size, unless you want a very fine filtration, better than sand by X3, X2, X or whatever. Then in that sense, we'll have to redesign it for you and give you a more surface area to achieve that. Otherwise, uh, apples to apples, it is the same.
Also, in some cases, we have helped customers reduce the vessel size as well, right? Because it allows for a higher velocity compared to sand, and also the density is lower, so
Yeah,
it can
yeah.
aid in
It can aid in
cases where there
understanding.
is in
Yeah,
cases where there's a requirement for a smaller vessel compared to
correct,
sand, right?
correct.
Right.
It all depends on the application.
Right. While filling media and vessel, there are chances of glass breakage or not. I think we mentioned that earlier, that our glass is
Normally,
extremely strong.
when you are putting a media into a vessel, we ask you to fill in about 30% of it with water, and then start filling in the media, because it's not about breakage, it's about the dust that would come out, and then your laterals where your nozzles and all shouldn't get that
Damaged.
pressure. So for all that, we recommend you to fill in 30% of the vessel with water before filling in the media, and then after that, once you fill the media, you close the vessel, and then you do a backwash until all that muck in that glass media goes away. It is then comes clear. Once the drain water is clear, then you are ready for it goes on duty.
Right. And also, filling water before installing the media helps with the media settling evenly. Or else, what happens is if you just put
Yeah,
media from one side, it might pile up on just one side and might
correct.
lead to uneven layering of the media.
Absolutely. Yeah, right.
Right. Does it aid in reducing colloidal silica?
Colloidal particles. Yes, you have case studies of that, Rahul.
Yes. So I think this depends on the micron sizing of the
Yeah.
particular particles, right?
Yes.
Extremely when you're working at an extremely low velocity and the particle micron size is conducive to being filtered out, like we mentioned earlier, there's a very high chance that you will see a good reduction in colloidal silica. But
Exactly.
again, it's all dependent on the micron sizing of the particular.
Correct.
Yes. Again, it all depends on piloting, basically. A good pilot trial will help us understand
Absolutely.
how.
I
Yes,
always suggest that you go for a pilot for all these type of cases and then prove it to them
yes,
and then upgrade it.
of course. This is quite interesting. If glass media gets biologically fouled, can it be cleaned and reused? And if yes, what is the method? Because glass media is expensive, right? So,
Whenever you remove the media out to replace as the vessel, you may have to clean it. You can clean it with water or with diluted hydrochloric acid and just give it a wash and allow all that muck which is stuck on it, and then you can get it as fresh as new.
right. Oh, okay, this is interesting. Does the lighter density of glass media result in lower water usage during backwash? And if so, by what percentage?
No, it's not about the lighter thing. It is about the anti-compaction technology. All these, the lifetime media, the long lifetime of the media, the durability, the delayed backwash, all this is because of the anti-compaction. The curve, you see that the curve of the media, the difference in each sizes of the media is very, very, very small. So that's why you have uniform openings throughout the bed of the media, and you will not. And that is why you need lesser pressure while filtration and backwash.
Perfect. Can this media, glass media, be used for rapid gravity sand filters
Yes,
instead
of
of,
course.
yeah,
We have done it. I think one in Spain has been done. We have pictures of it. Maybe we can share that.
yes, definitely. All filters are rubber lined from inside. How is how glass media is safe? Like, I think the question is how compatible is the glass media with the rubber lining inside of the vessel?
I'm not very sure. Only OEMs have to tell whoever has used rubber lining.
So I can speak to that.
They
I
can,
think we've used glass media for almost all types of
whoever,
vessels
yeah,
in all
whoever,
conditions, and it
exactly.
basically it is compatible with every vessel and every
See,
material that
another
sand is
thing is
compatible with.
because of this thing, the glasses are rounded. Now you take any other
Right.
media, glass media, they are not rounded. They have sharp edges. Ours do not have sharp edges at all to tear. If you can take it in your hand and just squeeze it up in your palms, nothing will
Yes.
happen.
Nothing will happen. No
So
cuts,
I
nothing.
don't think it will hurt your
Rubber
rubber
lining.
lining at all.
Right.
And there is no pressure within the vessel. The pressure is very limited.
Right. Uh, what is the filtration velocity in glass media filter? So what is the range of velocity that can be considered?
It depends on what micron you want to achieve, at which stage. Now you take stage one, we recommend 15 to 25 or even 30, depending on the inlet suspended solids. You take stage two, we go from 5 to 30. Stage three,
Right.
0.25. So it all
Right.
depends on
So
which application you're using. Normally, we go for stage one. That is the most fast-moving thing for all wastewater and water treatment and cooling tower side streams. So all that we can go from between 15 and 25, again
25.
depending on the inlet
Yes.
suspended solids.
Right. We can also go below 15.
You want to, but then it
Yes.
will be costlier for the client.
Yes. Again, someone has asked the MOC of the vessel. It is compatible with all materials that sand is compatible with.
Absolutely, absolutely.
How cost effective can glass media be for a drinking water plant with like 1 meter cube, like a very small plant?
Is cost effective.
It is cost effective in the long run. I'd say it provides a lot,
Yes, it is cost
like some
effective.
very robust protection to the RO membranes. We have case studies where manufacturers of small RO treatment drinking plants have seen a huge increase in the life of the RO membrane.
Right.
Possibly replacements after 2 years have been delayed by a year, and that's a huge cost saving in the end, right?
Absolutely.
Um, for RO feed, does it eliminate the need for cartridge filters?
Absolutely. 100%.
Yes, it does. We have case studies for that as well. Are there specific backwash settings that should be altered when switching to glass media? I think the pressure drop, the trigger pressure drop is something that we mentioned earlier, right?
4 kg.
So I think there was a slide,
Mixture pressure of 0.4 kg is what we normally recommend.
right?
So whenever you attain that, you can always go for a backwash.
Right. Okay, so one question yours, do you have activated media?
I must ask them the question, what is activated? How do you
So
activate glass media?
right, so activation is a very temporary process. Like I think Mr. Prosper would agree with me. Activation of media, putting a negative charge on media, so as it's claimed, can only last on the media for a couple of days. After which you need to have a zeta potential or a static mixer at the inlet of the vessel to continuously keep the media activated, or more than activated, charged, so it can attract a few heavy metals and other impurities.
Exactly.
So for that, any media, no media has has a charge permanently. It needs
Yeah.
to be charged on a constant basis, and we do provide the static mixer, the zeta potential mixers, which aid in that. So you can always get in touch with us for that, and we can help you with that. Is there any hardness limitation?
Beg your pardon?
Is there any hardness limitation? Hardness, water
No,
hardness.
seawater. We do even seawater.
Yes, actually, desalination is a huge
Yeah.
application
We
for
do
us.
even seawater. Yeah.
So, so there is no
No.
hardness limitation. Density of glass media, as mentioned earlier, it is ranges between 1.3 to 1.4, depending on the grade. You can assume it to it's 1.335 in most like for the
Yeah.
main stage.
Yeah.
Does it remove the need for a micron cartridge filter for a RO feed? Yes, it does. Can it be feasible to use up to 10 meter cube per hour flow or even lower? We work with flows as low as 500 liters per hour to as high as, like, the cases where we have worked.
We talking about the velocity or about the capacity?
Can it be feasible to use up to 10 meter cube per hour flow?
Okay, fine. Yeah.
Yes, for sure. Very versatile. It can be as low as 500 liters per hour and as high as, like, there's no limit to how high it can be. Pebble support required. This is a nice, good question.
Yeah.
Pebble support. So yeah, please,
Pebble
Mr.
support
Prosper.
again, it all depends on what your distribution is, your lateral distributions are. If you can go in for the strainer nozzles, then you don't need it. If the client is not willing to change the laterals, and because of the laterals will be openings, especially for MS vessels, then you may have to go for a support media. But we have coarse media, we have stage zero media, which can, I think, be used, because when you go for pebbles or any other outside substance, biofouling is not guaranteed.
Yes, you defeat the purpose of using glass media in the entire vessel. So one of the major advantages of using glass media is it can completely prevent the formation of biofilms. But when you do use pebbles or gravels at the bottom, there's a uh, there's a chance that it might be a conducive environment for biofilm or algae to grow. So we don't know. We don't say that you shouldn't use, because if your lateral openings are big, then you will have to use gravels and pebbles to cover the laterals, and then you can use a glass media above it. But like as Mr. Prosper mentioned, we also have a coarse media, the size of which is 2.5 to 5 mm. So that's a significantly larger size, and that is in most cases good enough to cover the laterals.
Absolutely. Yeah.
Yes, you can. But yes, there are a lot of cases where gravels and pebbles are used below glass media, and that is completely fine. It does not affect the performance of the glass media filtration whatsoever.
Except for biofouling.
Yes. Um, can this glass media reduce organic fouling and can be substitute of activated carbon filter vessel?
No.
Okay. Yes.
Activated
Then my
carbon works on for different parameters, that is for odor, color, and all that. So that we cannot assure. See,
right.
anything which is suspended matter, we can. Insoluble, we can remove. Soluble, we cannot. But carbon
Right.
is a different ball game.
Right. Is this your technology? How much local content is there? So, sir, this is a Spanish technology. The media is made in Spain. Both the types of media, the NW40, which is recycled, as well as the high-tech filter media, which is made from virgin glass, both are made in Spain and imported by us, Pure Auto Enterprises. We are NatureWorks' authorized channel partners. The the entire all the technology, the patent, and everything is held by NatureWorks, which is a Spanish company. But we do have a very strong support system and service in India. NatureWorks has two people who are working in India, one in the north, one in the south, full time. And we also, Pure Auto Enterprises, we have a team of more than 35, 40 people who are constantly here to support any industry anywhere in the country. Is media top up required on in the long run? No, media top up is not required. Like Mr.
No,
Prosper mentioned earlier, we've been selling this media for a very long time, and n- we haven't found a case where the media has needed any topping up or replacement till now because of the many factors that were mentioned earlier. There's no attrition loss mainly. What happens to sand is over a prolonged period of time and operation, sand particles tend to break or clump or compact in size, because of which the depth reduces over time. This doesn't happen to glass media, so essentially there's no need to top up or replace the glass media. Would you be sharing the slides with us? Yes, we can share the slides with you, and we will also be sharing the recording of the entire uh, webinar with you, and we also upload it on YouTube, on our YouTube channel, Pure Water Enterprises YouTube channel, so it is accessible to you whenever you need it. Do you have case study of glass media installation in textile plants? Yes, we do. We actually just presented one, and we have a few more. You can get in touch with us. So this is my personal contact details. Anyone attending who has attended the call today can get in touch with me for regarding anything, and I'll get back to you with any information that you might need. So glass media compared to other media, and what is its life? For the cost, you can get in touch with us, and we will walk you through it. And the life is, we claim 15 to 20 years, but there is really no need to replace glass media. So we don't claim it. We say 15 to 20 years, but like really it's a lifetime media. Vessels are rubber lined or epoxy painted from inside to avoid material corrosion. Again, it's completely compatible with any
yeah,
MOC.
yeah.
Can it be used for 3000 TSS, 3000 ppm TSS?
No, no, it
I
cannot
think
be.
it'll need a lot more of a pre-treatment before it can be
Yeah,
used,
yeah, yeah.
can be put in glass
You
media.
need to clarify. See, what normally we do for desalination is the intake is from the bottom of the sea, and we don't directly give it to the filter media. We allow it to settle with a clarifier, whatever, and then that supernatant is taken and fed into the filters for fine filtration. So
Right,
again, limitations of those kinds are definitely there.
right. Supporting media required for media bed depth, media depth or bed. Again, like I said, we have a coarse media which is 2.5 to 5 mm in size, which is in most cases enough to cover the laterals. You can also use gravels and pebbles to cover up till the laterals, and then you can use our glass media. It's completely okay. But we recommend using a full bed of only glass media to really get the full benefit of glass media. Is there any thumb rule for selecting the quantity of media and the size of vessel accordingly? For example, for 1 meter cube per hour flow, how much media quantity is required? You so you can get in touch with us and we can help you with the exact quantity required. But since the density of the media is 20% lesser than sand, I wouldn't say it's a thumb rule, but in most cases you can assume that it is 15 to 20% lesser the quantity, right? Than compared to
Yeah,
sand, Mr. Prosper.
correct.
Yeah. But you can always get in touch with us again and we can help you with the exact yes. What would be the effect if it is used in effluent treatment having a wide range of pH? Again, glass media is completely inert in nature. The pH does not have any say on its performance. So you can use it, sir. You have used the glass media of another company. That's perfect, sir. So you already know, you have already availed the benefits of glass media. Bore well water coming with much sandy particles. We have put back filter and filter before sand filter, but cartridges have to replace in 3 to 4 days. Its flow is 5 meter cube per hour. Mr. Prosper?
Yeah, sorry.
Yeah. Bore well water coming with a lot of sand particles, and they have put back filters and cartridge filters before sand filter, but they have to keep replacing it every 3 to 4 days. I think we need some
It all depends on the suspended solid load.
we need some water parameters before we can
Yeah,
help you. Yes, we can commit something.
correct.
You can get in touch with your particular requirement with the particular parameters, water parameters, in the parameters, and we can help you with the particular case study.
Yeah.
Up to what size of colloidal silica the glass media can remove?
But my knowledge not tested as yet. Maybe we can test that out.
Yes, I think for this, for colloidal silica, it does work for sure. It has an impact. It does reduce colloidal silica, but to what extent is very hard to determine without doing any pilot trials.
It
So
need to work with it, yeah.
yes, we need to do pilot trials, and we are very open to helping you with that. So you can always get in touch with us. Can we remove color and free chlorine in glass media filter? Uh,
Color?
no, color and free chlorine.
No. Nothing, as I said.
No, because
All
again, it works.
insolubles, we can remove. Solubles, we cannot. It again depends.
Yes,
in
it
one
works.
case here, in one case here, we are supposed to have reduced the iron content in the water, but it so happens that that part of the iron was insoluble. What is soluble cannot be removed.
We have cases where we have reduced iron and heavy metal presence, but like of course it depends on the size of the micron sizing of the colloidal particles. And basically, again, it does the job that a sand filter does. This filtration, but it does it a lot better. But it does not aid in color or free chlorine removal. Can it be used in MS vessel? Yes, so it can be used in an MS vessel. It can be used in any vessel, any MOC, which you use with sand. Can the media reduce BOD?
No.
No, it does not
No.
reduce BOD. Again, the primary use case of glass media is only for filtration, very fine filtration. So,
okay.
So I think we have answered almost all questions. We'd be very happy to. And is this glass media manufactured in India or Spain? This media is manufactured in Spain. Pure Water Enterprises is NatureWorks' authorized distributor in India, their partner in India, and we work with them so we can help you with any inquiries. What is the okay? I think the question answer session has been going on for a while, more than half an hour. So I think I'll take one last question, Mr. Prosper. What is the filtration quality? And if you have any questions, if anyone has any questions which has not been answered, you can always get in touch with me. You can drop me an email, drop us an email. I work with Pure Water Enterprises. and I'll help you with all the information that you need. The last question that we'll take for the day is, what is the filtration quality after media in micron terms?
Micron.
Sorry?
1 micron.
1 micron. Again, to achieve filtration down to 1 micron, we will help you specifically design the vessel and the system in a way where it can really give you the committed results.
Yeah.
But yes, down to 1 micron.
Down to 1 micron, yeah.
Okay. All right. So thank you so much to everyone. I think we still have more than 100 people present even now after half an hour of the webinar getting over and during the question answer session. So thank you so much everyone for
Big
attending
thanks
this
to all.
session.
Big thanks to
We
all.
appreciate it. And I hope we were able to give you some important information and answer a lot of the questions that you might have had during the presentation. And I hope that this really, it can really aid in all kinds of filtration processes, really. So we hope to get in touch with a lot of you over the next few days and see how glass media can fit into your scheme of operations and how we can help your plant perform better. Thank you, Mr. Prosper.
Thanks a lot. Thanks
I
a
will
lot to
be,
all who attended.
yes,
Thank you,
we
Rahul.
will be, thank you.
Your team.
Thank you.
To thank your
Of
team too.
course. Thank you everyone for attending it. And we will be getting
Thanks,
in touch with
Viplo.
everyone's, yes, thank you. And we will be getting in touch with everyone with a few follow-up emails through which you can get in touch with us and we can take the conversation forward.
Okay.
Thank you, everyone.
Thanks a
Have a
lot.
great day. Have a great day. Have a good evening.
Yeah, bye. Good evening.